In this video, we will create a simple test case to connect to a broken switch and execute the switch show command. So let us begin by creating a test case file or test suite that shall hold our test case. So first we will create a test case file in a plain text format. Next, we are required to add the SSH library provided by Robotframework that provides us with the keywords to connect to a remote system. Next, we will create some variables and assign values to them which can be used in our test cases. We will create a variable to hold the IP address, to hold the username and password for the switch, and we will create a variable that holds the switch show command that we wish to run on the remote system. Having created our variables, let us proceed with creating a user level keyword. A user level keyword is a keyword which can be used in a test case and is composed of the keywords provided by the Robotframework. So here we are creating a user level keyword which will connect to the switch and then log in using the username and password. So let us write documentation for our user level keyword. Let us go and see what keywords does the SSH library provides us to connect and log into a remote system. So the first keyword that the library provides us is open connection, which takes the host name or the IP address of the remote system, and a timeout value which opens a connection to the remote system. And the second keyword which is required is the login keyword, which logs into the remote system once an SSH connection has been established. So now we are ready to write our test case. Having included the library, created the variables and a user level keyword, we can proceed with writing our test case, which actually connects to the switch and runs the switch show command. So the user level keyword which we created is used as a setup to our test case. So before the test case is executed, the setup is run, the keyword in the setup is run, and if that keyword fails, if there is no connection to the switch or we are not able to log into the switch, the test case is marked as failed, is not executed. We will tag our test case with a tag of switch show, and let us begin writing our test case now. So we have created a variable called command output, which will hold the return code or the output written by the start command keyword. The start command keyword runs the switch show command on the remote system and returns immediately. And then we can use the should contain keyword with the read command output, or we can use should match regex pattern keyword, which will go ahead and match the pattern once it is found in the output of the start command. So we have already saved the kind of output which is returned by the switch show command, and we will take one of the keyword value pairs, such as a switch state is online, and we'll try to find whether this particular keyword is present in the output returned by the start command. The first part inside the simple parenthesis indicates ignore case. So the case of our keyword and its value does not matter. Those will be matched against the output. And we are using the close connection keyword to close the connection to the switch now. So we will run our test case now, and the test case passes. The output is displayed, is logged by the robot framework, and we see that the switch state online keyword value pair which we were searching for is present in the output. So we are running the test again, and this time we have changed the keyword value pair which we were looking for. We have changed the ignore case keyword indicator modifier, and hence the test case fails. We can see the report which is generated by the robot framework, which shows the test case result. We were looking for the keyword value pair switch state is offline, and that is not found in the output thrown by the robot framework, which shows that switch state is actually online, and hence the test case fails. So this report as well as log is automatically generated by the robot framework, and it indicates the time taken for execution of each of the test cases. Even though the switch ID has matched the switch ID thrown by the switch show command, the test case has failed, and this is simply because of another error which says the failed step is clearly shown, that close connection does not take any arguments, but it has got 3 arguments. So maybe by mistake I have left some blank spaces next to the close connection keyword, which it has taken up as arguments, and that is the reason the test case fails. So let us go and get rid of those blank spaces. So next we will create a test case to run 3 more commands in Robot Framework. And we will use the for loop of the Robot Framework to run these commands one after the other. So for this we are going to create a list variable, and which is similar to an array, and we will put the 3 commands in this list, and then we will use the for loop to iterate through this list and run each of the commands one after the other. So our list variable which holds the command is ready. Now let us begin writing the test case. So again we will give a setup condition where we will use our user level keyword. And we have created another user level keyword which holds the close connection keyword, which will be the tear down option for our test case. So once the test case is complete, the tear down is executed to disconnect from the switch. So to use the for loop, it begins with a colon and the word for. The for loop is very much similar to the for loop which we find in the Python programming language. So for a single command in the list, execute the body of the for loop. The body of the for loop is indented by one column. So the for loop will take each of the commands from the list and execute once for each command. Here we will simply use the read command output keyword, which will read the output of the command which has been run, and we will hold it in a variable which is stdout and just log that particular output. So now we can run our test case. The test case has failed, and it is because I have misspelled the user level keyword. So the setup condition failed, and hence the test case failed. So we will run only the test case which has a tag of multiple, and let us see now whether the test case passes or not. So we have got the output of the first command. Yes, the test case passes, and we have the output logged by the Robotframework for each of the command with timestamps. And see, it shows the status of the fans. Fan 1 is okay, 2 and 3 are okay. It shows the status of the power supply, as well as the zone show and alias show command has also passed. Another important feature of Robotframework that I would like to talk about is the execution profile. Here we are using the default execution profile provided by the Robotframework to run the test cases, which is called as PyBot. It is a Python script which uses the entry point provided by the Robotframework to run our test cases. Robotframework allows us to choose any method which we want for execution of test cases. So in this method, the execution of test case follows in a sequential order. The test cases are executed one after the other. Now if we wish to have our test cases or test suite files execute in parallel in a multi-processing or in a multi-threading manner, we can write our own custom Python execution script to do that. There are third-party Python execution scripts also available on the internet, which makes a parallel execution of test cases and test suite files in the Robotframework. So we can choose a custom script and then give a path to the script which we want to run our test cases through the robot framework.